Imagine 5 friends standing in a row. Friend 1, friend 2, friend 3, friend 4 and friend 5. And they decide that we will stand and take a picture by ensuring that no two adjacent people are wearing the same colored shirt. And they have choices from these 7 colors: violet, indigo, blue, green, yellow, orange, red. In how many ways can these 5 friends wear their shirt colors? In how many ways can they choose so that no two adjacent people are wearing the same color? Assume that the first person, whoever he is, he will stand in the first place only. I'm not talking about the ways in which they can shuffle their places. All I'm saying is violet, indigo, violet is one way. Violet, indigo, blue, green, yellow is another way. Blue, green, yellow, yellow is another way, and so on. In how many ways can you make these 5 places colored so that no two adjacent places have the same color? Let us try answering this question. The first person has 7 ways. The second person has 1 way less than the first person because first person has chosen a color which second person cannot choose. Think about it. So he has 6 ways of choosing a color. Third person need not worry what the first person is wearing, but should worry what second person is wearing, because the rule is your adjacent person should not be wearing the same color. So the third person will have 1 color less, namely the color that the second person is wearing. And hence 3 will have 6 colors. And 4 will again have 6 colors similarly. And 5 again, apart from the color that 4 is wearing, 5 has 6 colors. So the answer to this question is 7 into 6 into 6 into 6 into 6 happens to be 9072. Well, let's keep this question aside and ask some other question. Given this graph, look at this path with 5 vertices. In how many ways can you color them with lambda number of colors so that no two adjacent vertices have the same color? Sounds familiar? This is the same question as the previous one. So the first one will have lambda colors for its choice. Second one cannot have the same color as the first one, so it will be lambda minus 1. Similarly, lambda minus 1 for the third vertex, lambda minus 1 for the fourth, lambda minus 1 for the fifth. So it is lambda times lambda minus 1 whole to the 4 for a path with 5 vertices given lambda colors. So the question, in how many ways can you color a given graph G, which is a path with 5 vertices with lambda colors, such that no two adjacent vertices are the same color? The answer is lambda times lambda minus 1 to the power of 4. A point of confusion. You are probably wondering, why am I writing 7 for the first person in the previous example? That's because he can choose it in 7 ways. Why is it 6 for the next person? For each way that he has chosen, this person has 6 ways. So it is 7 into 6. It is the rule of product that we have been discussing. And this could be a point of confusion. Get this clarified by thinking about it for a few minutes before going further. So, all in all, we have shown that given a path, this is the total number of ways in which you can color the given graph properly. Properly means, we have discussed this. No two vertices of this, which are adjacent, two nodes that are adjacent cannot have the same color. In how many ways can you color with this constraint is what we mean by proper coloring. Right? Now, if I give you in general a graph G, and if I ask you given lambda colors, in how many ways can you color the given graph G? That's a very non-trivial question, not at all easy to answer. It is not as simple as the path graph that we just saw. It's going to be deep, it's going to be very subtle, it's going to invoke some advanced thinking. Okay, let's go ahead and see that for a general graph. How do we find out what is the total number of ways in which you can color a given graph G with lambda colors? Anyways, a definition. Lambda into lambda minus 1 whole to the 4 is called the chromatic polynomial of the given graph G. So we denote it by C of G. C stands for chromatic polynomial of G, and that is equal to lambda times lambda minus 1 to the power of 4 in the case of a path with 5 vertices.